Hi, this is Lee from Proxylity. We're going to be demonstrating UDP Gateway as a way to do remote packet captures in today's walkthrough. All right, let's just pop on over to the repository and we'll take a quick look at what this solution is. So this is one of the example solutions that exists in our GitHub public repository for them. It's one of many. You check them out and see some of the other things that we can make easy. This packet capture solution comes up is from time to time because it's not always simple to see what the internet is receiving from your solutions, right? It's easy to do a local packet capture using Wireshark or anything else, and those are excellent tools. But they'll only tell you necessarily what's happening on your local network, your local device. You can do remote using SSH, and that's great, but sometimes a quick and easy solution is better. And that's what we have here with this packet capture solution. It's also just a nice demonstration of the capabilities of UDP, to be frank. So what we're going to be building is a pretty straightforward serverless architecture that listens for UDP and WireGuard traffic, tunnel traffic, goes through listeners on UDP Gateway, transformed into JSON representations and delivered to an SQS queue. Right, so that queue is going to receive those, and then a Lambda function with an SQS trigger is going to service that queue, read those packets, dissect them, and broadcast the information it was able to extract to an AppSync event channel. Pretty snazzy service. Love how this works, which is going to send them out via WebSockets to the front end. And that front end is just a simple HTML front end that's generated by a Lambda function, rendered as HTML. All right, so that's what we're going to be deploying. Let's pop on back to or scroll on down the README a little bit, and we're going to see how we're going to be deploying it. Because it uses WireGuard, is common for these kind of solutions. We need a peer key for the client, so we're just going to go ahead and start off with generating that that peer key. So here we are over at the command prompt, and boom, that's done. The next step is we have to build and then deploy the solution, and that key that we just generated is going to be a parameter that's passed into the deploy call, right? So that's going to be used to tell our WireGuard listener in UDP Gateway which peer should be allowed to connect. Now, the listeners support as many peers as you want, but in this case, we're just going to be using one key from this local WSL instance. So we're just going to start that build and deployment process. It's going to stop when it gets to deployment because we're using the guided option here. But while it's working on the build, let's go back and have a peek at what's coming next in the deployment process. So once that's done, we're going to get the outputs and use the outputs of that stack to populate some environment variables that we're going to be using. But the important point being that there's a UDP endpoint and there's a WireGuard endpoint, and those are going to be separate listeners, separate ports provided by UDP Gateway that we use to send traffic, depending on which method of capturing it we want to use. All right, so it looks like that build is finished, so to come back here and just walk through the deployment. It's just asking us the stack name and region. We can see that public key there. One of the things that I wanted to call out, however, is that because we are using a Lambda function URL as a really simple way to build that user interface, there's no authentication, right? So we're just going to be accessing that with the browser, so we can't really do the IAM-based authentication, or there'd be lots of different ways to get that to work. You could use Cognito, or you know, there's just a bunch of different approaches. This this solution, this packet capture solution, doesn't address that, doesn't put any authentication on it. So the plus side, you can share the URL with a coworker in the room or on the other side of the world, and you can both see live packet captures happening based on the traffic that's going in. That can be helpful for diagnosing and collaborating. But if you aren't just like standing up the stack, using it and tearing it down, and you're going to have a persistent URL like that, probably should put authentication on it. It's just beyond the scope of this example. All right, so we're going to say yes, that's actually okay, and then go through with the rest of the deployment. And then while that's running, pop back to the README. That deployment's going to take a couple minutes because it's creating IAM roles fundamentally. That's really the slowest thing that it creates. So once that's done, yeah, we'll get those outputs and we will assign them to variables, and then we'll use that to set up a WireGuard interface. We're just going to call that capture, and then we'll stand that up, and then we'll start sending out packets over both plain UDP and WireGuard. All right, so meanwhile, while that's running, how it works. We talked about that a little bit, but the UDP client, now UDP client could be one of many things here, right, that you might want to packet capture. Could just be sending test packets like we're going to be doing here. Could be radius authentication. You might be wondering about some kind of authentication problem that's happening during radius authentication from your access point, or just trying to get a picture of what's being sent. Could be syslog, could be mavlink from coming in from your drone fleet. It could be any number of things coming in over UDP or over WireGuard, and you just want to get a picture of those things. When those packets hit our listeners, Proxylity's UDP gateway listeners, if it's WireGuard, we're going to terminate that WireGuard connection for you, right? We're going to handle the handshake and the key exchange and generate their ephemeral keys, and then deliver just the transport packets to your destination. So in this case, the SQSQ that we see here, it's being used by both the plain UDP and the WireGuard. And what's ending up in there are just transport packets when it's WireGuard. All right, actually, it looks like that stack is already deployed. So here we are. It's done, and we can see those outputs in the green text there. So just continuing on with the instructions from the README, we're going to grab that stack output and pop that into environment variables. I'm just going to do that real quick. And then once that's done, we can set up our WireGuard interface. So it's just using the standard WireGuard tool that's available on any Linux platform, basically, and Windows and even ESP32. So the interesting points here is just to focus in on, we're using the WireGuard endpoint. We're using the server key generated by Proxylity for that endpoint. That's the public key that we're configuring here. And we're assigning it a single local network IP as the allowed IP. So only traffic that we're sending to this specific IP is actually going to traverse the tunnel. And that's how we're going to separate testing WireGuard from testing just plain UDP. So let's go ahead and finish that up and set up that tunnel. There it is. So now we've got a WireGuard tunnel running. Now, the fun part, we can start sending, oh, wait, forgot one thing. We have to open up the user interface. So that's stack deployed, but we haven't actually opened up the user interface. So we need to do that here real quick. So how do we get that? Well, that just comes as one of the stack outputs. That's the URL right here for this instance that I just created. So we can transition back over to the browser. You can see this is that live packet capture interface. There's nothing in it yet because we haven't sent any packets. I'm just going to switch back to the command prompt here and keep that browser up in kind of a picture-in-picture way so we can see what's going on kind of in real time. So first things first, we're just going to send a single plain UDP packet, right? And we'll just do that with echoing to ncat and using those environment variables. Boom, there it goes, and there it shows up, right? We just saw a little flash, and there's that UDP packet, and there's that hello packet 123 content that we sent, that we sent through down below, right? Okay, so that one came in over plain UDP, so it's got some pretty basic information in it. Now, if we send one over that local address, or towards that local address that we assigned the tunnel, this is going to go out via WireGuard. It's going to go out as again as a UDP packet, but it's going to be targeting port 1234. It doesn't matter what port it is because everything directed at that IP is going to go out over WireGuard. And there it shows up again. Now this one being a WireGuard packet has a lot more information because there's information about the encapsulated IP packet in here as well. So we can see that where it was destined for, where it came from, what port it was on, right, and what port it came from, and then we can see the content is exactly what we sent down below, hello packet 456. Okay, so that's interesting, but just to make it a little more real, let's rad test. 10.10.10.11, 18.12. Whoops, got a couple arguments. Leave password, as port 1. All right, so this is sending out radius requests, just test radius requests. And it's going to retry 3 times just because that's what it does. You can see those packets are also showing up in here. Again, this is small. We'll zoom in on it here in a second. I just want to show that those are actually getting through. Actually, why don't we just zoom in to it now? All right, so here's that first plain UDP packet labeled as UDP. It didn't have a protocol associated with it since we're just sending text. The second one, same kind of idea, but this time sent over WireGuard, so it was an encapsulated UDP packet. Now we've got encapsulated radius packets, and here we've got a little bit more information. We've dissected them a bit, so we've extracted the radius access request codes, the identifier, the length, the authenticator, and some of the attributes that are inside of it. So this is kind of the power of this kind of remote-based solution, is that this is totally customizable. So the code is really straightforward. You check out the example repository. Easy to customize. Agent can do that all day long and customize this solution. So I guess one more thing, just because I like doing it. Also a little bit demonstration. But here's a WireGuard solution coming through, or WireGuard packs coming through, but we're going to send out actually a bunch of them this time. Boom, 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 and there they go showing up in the solution. So that's pretty much all there is to this demonstration. We're going to leave it at that. If you'd like to check out some more of the example repositories covering Mavlink, DNS, and other protocols, they're there out on GitHub. Thank you.